we're going to actually pick up a little bit on the notes that we went through yesterday and add just a bit to those. We will not be getting to an assignment today, but we probably will at some point tomorrow. Today, though, I want to expand a little bit on where we were, add on to those notes, and in particular, learn about three important terms. So you hopefully remember that yesterday we figured out the basic shapes of sine and cosine graphs. We kind of went back to how you graphed when you were in middle school, plugged in some numbers for x and figured out what y was. And we figured out that sine pretty much always starts in the center. On the y-axis, it's on the center, and it goes up, down, and back to the middle. That was the basic shape for sine. Cosine, you kind of have a U shape. It starts at the top, goes down to the bottom, and returns to the top. And I told you yesterday that the quicker you remember those two basic shapes, the easier everything in this chapter is going to be, because pretty much salad? All right. Because pretty much everything in this chapter is going to be variations on that. Now, we did learn one other important thing yesterday, which is that sine and cosine graphs also keep repeating the same pattern over and over again forever. You have that basic up, down, back shape for sine, but then it does it again, and it does it again, and it keeps on going in both directions. That's because we learned that every 360 degrees, you get back to where you started from when you go around the circle, so it is just repeating that same pattern over and over again. What you call that, when you repeat the same pattern over and over again, is we call that a periodic function. A periodic function is just a function that repeats a pattern at regular intervals. It keeps doing the same thing over and over and over and over and over again. And I've got some pictures there that are showing you 4 different periodic functions that are not directly trig functions, but they are doing the same thing over and over again. Turns out that there actually are a lot of things in the real world, especially, that do make periodic functions. And I have some pictures on the next screen that get that idea across. You can actually see up at the top, they have a picture that's looking at like average temperature in different months of the year. And this is, by the way, in degrees Celsius, which is why you do have averages that are below 0. That just means below freezing when it's Celsius. But you can see that typically it gets warmer in summer, it gets colder in winter. And then the following year, it gets warmer in summer, it gets colder in winter. And you actually end up with a graph that makes sort of like a sine wave. It keeps going up and down over and over again. At the bottom, you can see a picture that's showing a basic heart monitor. You certainly hope that your heartbeat is periodic, that it's doing pretty much the same thing over and over again. You know, if suddenly it went all crazy, that's a problem. And of course, if it went flat, that's an even worse problem. So, you know, you want it to keep going up and down in the regular beat that it's supposed to. Now, with a heartbeat, it does sometimes speed up and sometimes slows down, but the basic pattern is still periodic like that. A lot of things do end up being periodic over the course of day and night as well. And at the top left, I know you can't really read the labels on that, but it's looking at things like blood pressure and pulse rate. Typically, your blood pressure and pulse rate go down at night, they go up during the day. And, you know, so again, it's a periodic pattern where it keeps changing in a regular interval. Officially, what happens when you have a periodic function is that if you plug in x plus some number, you get the same thing as if you plug in x. Like for sine and cosine, if you plug in x plus any multiple of 360, you get the exact same answer you started with. Doesn't have to be 360, but it does need to mean that every certain interval you're going to get the same answer for y. When you plug in even amounts that you add on to x, you always get the same answer. One thing that you're going to be asked to do when you both are doing worksheets and when we get to the next test at the end of this chapter, and I know there's some of you that just took the last test yesterday, and no, I didn't get it graded yet, unfortunately. That's because I was basically lazy last night, but oh well. Hopefully you guys will do as well as everybody else did on it. You're going to be asked to look at some pictures that are not necessarily trig functions, but you'll be asked to decide whether things are periodic functions. And again, the whole idea is that you want to see, does it repeat the exact same pattern over and over again? Like on that top graph, you can see that it kind of makes an M, and then it goes down a little bit lower, and it has another hump. Then it makes another big M, it goes down a little bit lower, and it makes another hump, and it does that same basic pattern over and over again. And even though it's a complicated pattern, you can see some stuff going up and down on the bottom one. The difference there, though, is it's not doing the exact same thing over and over again. What the bottom graph actually might be showing you is the sort of pattern you might see like if you were looking at an oscilloscope during that's looking at sound varying, and you have things that as they get louder, you have a higher thing, and as it gets lower, it's softer. That's the kind of thing that the bottom graph might be. But again, periodic function, it repeats the same thing over and over again. So yeah, the top one is periodic, the bottom one is not. Okay? That makes sense to everybody except the Swiss. All right. Turns out that all trig functions are periodic. What we're going to care about are sine and cosine, but it would also be true if you did tangent and cotangent and cosecant and secant. All of those are periodic. They're going to make the same pattern over and over again. We've already said what it looks like when you do a sine graph or when you do a cosine graph, but the whole idea is every 360 degrees, you're going to repeat that pattern. Okay? And I know I've got people that are frantically writing things down, so I'll take a breath here and do that. I'm actually also trying to record this for Emma Bacha so that she can hopefully learn this as well. Right now I've got people in 4 different classes that are quarantining, so they have to. His wife is in the hospital, and so he's quarantining because she's sick. And all right. Anyone need more time with that? I'll get back to you guys with the beginning of it later, but that's what we got. So there are a couple of ways that we talk about periodic functions. One of them is we talk about what we call the period, or another word for that exact same thing is the wavelength. When you get into like physics class, you'll talk about wavelength in places, but it's the exact same thing as the period we deal with in math. And it just means how long does it take before you start to repeat. For sine and cosine, the period is 360 degrees. Because every 360, I start repeating the same graph as what I had before. Here's some different graphs on here, and each of them has a period that you could look at the graph and figure out what it is. If you look at that first one, anyone tell me how long it takes before the first one starts to repeat?
1.
1 is right, yeah, because it starts up at the top again at 1, it starts up again at 2, it's up to the top again at 3. Every 1, it starts to repeat. You go down to the bottom graph I'm pretty sure it's probably hard to read the numbers across the room, but they basically end up counting by fives. And that's why it's going to end up having a period of 5. And the middle one, well, it's counting by ones. This is a basic sine graph, and you can see it's back to the middle when we get to about 6.2, which happens to be 2 pi. Yeah, that is what's going to end up happening with it. It's just a sine graph graphed in radians instead of degrees is all it is. So again, period just means how long before it starts to repeat. That's all that term means. Another term that we're going to talk about is what's called the center or the vertical shift. This is actually really similar to when you were back in algebra class and graphing lines and you cared about the y-intercept, because it's pretty much the same thing. It's more or less like, where do you start? Where are you at the beginning of the graph? The center is the y value that's in the middle of the graph, and a lot of the time that number happens to be 0. When we were looking at sine and cosine graphs yesterday, the middle of the graph was at 0 on all of them. It was centered on the x-axis, and you went up and down from there. You can change that, and we'll talk about how you do mostly tomorrow. But it is, where's the middle of the graph? That's the center or the vertical shift. Again, I got some pictures here that we're going to try and look at. Can anybody tell me where the center of the first graph that I have up there is? Probably somebody toward the front that can actually read the numbers on there. Or, if we prefer, we could look at any of the other ones. Can anyone tell me what the center of the middle one is? Center, again, just means the middle of the graph, up and down. Yeah.
The first one is 1.
The first one is 1, because it's labeled on the side everything from negative 0.5 up to 2.5, and in the middle of the graph is 1. From there, it goes up to 2, and it goes down to 0. Okay. On the second one, I'm pretty sure the center of that graph is going to actually be at 2, because right through the middle of there's a 2. It ends up going up to about 5 and down to negative 1, the way this thing's marked. Okay. And on the bottom one, the center is at a half or 0.5. It's actually marked off in like 0.2 elements, but it is going to be, half that would be in the middle of that. So center, again, or vertical shift, is just how far do you go up to get to the middle of the graph going across. You cut it in half going across, where would that be? That makes sense to everybody. The third key term that we're going to talk about is what's called amplitude. And amplitude means how far do you go above and below the center? How far up and how far down do you go when you're looking at a graph and you see the center on it? Yesterday, when we looked at those basic sine and cosine graphs, the amplitude of both of them was 1. Because the middle of the graph was at 0, you went as high as 1, you went as low as negative 1. So you go 1 up, 1 down. That's why it's got an amplitude of 1. Sometimes people will talk about that as being the height of the graph, although really what it is half the height, because it's just from the middle to the top that you're measuring. Okay. On the one I have on here, where the top appears to be at 1 and the middle appears to be at 0, I'd say the amplitude is a half. And that's just how far is it from the middle to the top. That's what I'm looking, or the middle to the bottom. You can look at it either way. So again, here's some graphs, and we're going to try and figure out what's the amplitude of these graphs. So on the first one, the marks that are labeled there are 0.2, 0.4, 0.6, 0.8, and 1. And I'm pretty sure the center of that graph is at a half. Anybody know what the amplitude of this would be? True.
5.
So,
Not 5.
but you're on the right track.
2.5.
So what I'm pretty sure it's really going to be is 1/2 or 0.5. Because again, the bottom 0, the top is just 1. The middle is halfway between 0 and 1, and from the middle to the top would be, how far is it from 1/2 to 1? That's going to be 1/2. And in fact, I'm going to show all 3 of these on here. The top one would be 1/2. The middle one, I believe the center is at -1 and it goes up as high as about 5. That's why I would say that the amplitude is 6. And actually, I may be wrong on that one. I need to look at that a little bit more. Actually, no, the center's at 0 and it goes up to 6, so that's why it would be 6. And on the bottom one, it's really hard to see where that is, but it turns out that the center, I believe, is at 2 and it goes up as high as 8. That's why it's also going to be 6. Okay. So again, you just figure out how far is it from the middle to the top. That's what amplitude is. Any question with those 3 terms? So we're going to figure out tomorrow how changing around the equations of like sine and cosine functions changes those 3 things. And again, it's a lot like if you move the slope or the y-intercept of a line and how you change them, but that's what we're going to be looking at now.